Okay, so for our last topic for this lesson, we have the operations and radical expression. So actually, it's very significant when it comes to mathematics that we are familiar when it comes to the operations of different expressions. Especially when it comes to the radicals, we should be careful in considering the rules of or the laws of radicals. And at the same time, actually, it's the same as adding, okay, adding the polynomials because we combine the like terms. Okay, so here in this case, it's based on the index. Okay, so we add or we subtract same index or same indices and radicands. Okay, so let's start. Let's have an example. Okay, so to start, we have your number one, a square root of x minus b square root of x plus c square root of x. So as you can see here, we have the common term here, which is square root of x. Okay, we have here the square root of x. So as you can see, we can simplify that as the quantity of a minus b plus c square root of x. Okay. Another example, we have the cube root of xy. Okay. So as you observe here, uh, we have the common index, which is 3, and then the radicand, which is xy. Okay. So simplifying that, we have here 4 plus 3 minus 9. It's simply negative 2. Okay, so here we have negative 2 cube root of xy. And then we have another example, 4x squared of 2 plus y cube root of 3 minus x squared 2 plus 2y cube root of 3. So again, we need to combine those who have the same index and radicand. So here in this case, we have 2, which is the square root of 2 and the cube root of 3. Okay, so combining that, we'll have this 4x minus quantity 4x minus x square root of 2, and then quantity 2y plus y, the cube root of 3. And 4x minus x is simply 3x, and then 2y plus y is 3y. Okay, so therefore we have here our final answer as 3x squared root of 2 plus 3y cube root of 3. Another example, the cube root of negative 2 minus the cube root of negative 16. Okay, so again, uh, we need to consider, okay, the loss of radicals to simplify this. So for instance, we have here negative 2. Let's divide it, and we can have factors negative 2, which is negative 1 and 2. Negative 16 as negative 8 times 2. Okay, so again, applying the laws of radicals, we have your cube root of negative 1 times cube root of 2 minus the cube root of negative 8 times the cube root of 2. Cube root of negative 1 is negative 1, and cube root of negative 8 is negative 2. Okay, so combining that, we'll obtain negative 1 plus 2, that's 1. Okay, or simply the cube root of 2. Okay, so again, uh, be familiar with the laws of radicals. Okay. Another example. So let's try to evaluate this, which is square root of 98 minus 2, square root of 200 minus 3, square root of 32. Okay, so again, let's utilize the laws of the radicals. So here, 98 can be expressed as 49 times 2. 200 can be expressed as 100 times 2. 32 can be expressed as 16 times 2. Okay, so we have here the square root of 49 times square root of 2 minus 2 square root of 100 minus square root of 2 times the square root of 2 minus 3 square root of 16 times square root of 2. Okay, Square root of 49 is 7. Square root of 100 is 10. Square root of 16 is 4. Okay, so that's 7 square root of 2, and then negative 2 times 10, that's negative 20. Negative 3 times 4, that's negative 12. Okay, so combining this again, we have the same index and we have the same radicand. Okay, so 7 minus 20 minus 12, that is simply negative 25. Okay, so our answer here, the simplified form or the final answer here is negative 25 square root of 2. Okay, another example. 2 times the square root of 2 over 3 or 2 thirds minus 4, the square root of 3 over 8 minus square root of 1 over 24 plus the fourth root of 36. Okay, so again, don't forget the laws of radicals here. Okay, so here we have 2 thirds. To simplify this, let's remove, okay, the radical in our denominator. So as with the 3 eighths. Okay, so in 2 thirds we multiply by 3 over 3. And then the 3 over 2 cube, we multiply it by 2 over 2. Okay. And then for the square root of 1 over 24, so as you can see here, we have the 2 cube times 3, which is 24. So that's 2 cube. We need another 2 so that we can have the square root. And then 3, we need another 3 to have our square root. And then the fourth root of 36, we can use the square root of the square root of 36. Okay, so that's law D, right? Law D. Okay, so now simplifying this. So that's 2 square root of 6 over 9 minus 4 square root of 3 times 2 over 2 raised to 4 minus 5 square root of 2 times 3 over 2 raised to 4 times 3 squared plus the square root of 6. Okay, so square root of 36 is 6, and then we have here the square root of 6. Okay, square root of 6 over square root of 9, square root of 6 over the square root of 2 raised to 4. And then we have the square root of 6 over 2, square root of 2 raised to 4 times 3 squared. Okay, so as you can see here, we can eliminate the radicals in our denominator. So we have here 2 times the quantity of square root of 6 over 3 minus 4 times the quantity of square root of 6 over 2 squared. Okay, minus 5 times the quantity of square root of 6 over 2 squared times 3. Okay, plus square root of 6. Okay. So simplifying that again, we have 2 squared, that's 4. 2 squared times 3, that's 12. Okay, then let's have the common factor here, which is square root of 6, right? We have the square root of 6 here. So 2 thirds minus 4 over 4 minus 5 over 12 plus 1 times the square root of 6. So let's simplify inside the parentheses, which is 4 over 4 is just simply 1, right? So negative 1 plus 1, that's 0. So 2 thirds minus 5 over 12. So LCD, which is 12. So 12 divided by 3, that's 4 times 2, that's 8. Okay? 8 minus 5. So 8 minus 5 is 3 over 12, or simply 1/4. So we have here square root of 6 over 4. Okay, the square root of 6 over 4. Next example, the square root of 2r cubed t cubed plus the square root of r cubed t squared plus the fourth root of 4r raised to 6t raised to 6 minus r squared square root of t squared over r. Okay, so again, let's utilize the laws of radicals here. So square root of 2 r cubed t cubed can be expressed as square root of r squared t squared times 2 rt. Okay, so we extract here a perfect root. Okay, same with the second term, which is the square root of r squared t squared times r. And then applying the law of radicals d, low d. Again, the square root of the square root of 4r raised to 6 t raised to 6. Okay, and then uh, we need to remove, okay, the radical in our denominator. Okay, so here in this case, we need to multiply it, the numerator and denominator by r. Okay, and then let's simplify again. So we have here the square root of r squared t squared times the square root of 2rt plus the square root of r squared t squared times square root of r plus the square root of the square root of uh, the quantity 2r cubed t cubed squared minus r squared square root of the t squared r over r squared. So again, uh, we can eliminate now. Okay, we can eliminate now the radical in our denominator. Okay, the square root of r squared t squared is simply rt. Okay, so that's rt square root of 2rt plus rt times the square root of r. And then we have here again 2r cubed t cubed. Okay, it can be expressed as r squared t squared times 2rt, right? Okay, it's the same actually with the first term. If you observe the square root of 2r cubed t cubed. Okay, and then again we can eliminate the square root. Okay, in our denominator, it's just simply r. Okay, so again, as you can see here, in our third term, we have the square root of r squared t squared times the square root of 2rt. Okay, and our denominator square root of r squared is just simply r. Okay, so eliminating that, since we have r squared, we multiply it. So r squared by r, that's simply r. Okay, times t squared of r. So rt squared of r. So that's the last term. Okay. Okay, and then the third term here, again, square root of r squared t squared is just simply rt. Okay, it's just simply rt. Okay. Now, so as you can see here, we have the common factor of the square root of 2rt, and then we have here the square root of r, right? So simplifying this, actually, here the rt times the square root of r minus rt square root of r is simply 0, right? It's just simply 0. Okay, so we have here rt square root of 2rt plus rt square root of 2rt. So we have 2rt square root of 2rt. Okay, again, uh, the second term and the fourth term, okay, is just simply 0. Okay, it's just simply 0. Okay, so that's for the addition and subtraction of radicals. And then second to the last one, we have the multiplication. Okay, we have here the multiplication. So again, same index. Okay, same index, and we need to use this law. Okay, the m root of a times the m root of b is the m root of ab. Okay. For instance, number one, the square root of 2 times square root of 3. So as you can see here, it has the same index, right? So that's square root of 2 times square root of 3. That's simply square root of 2 times 3. Okay, which is square root of 6, right? It's just square root of 6. And then the cube root of 4 times the cube root of 2. Again, multiply the radicands here. So 4 times 2, that's 8. So the cube root of 8 is 2. Okay? Another example, square root of 3 plus the square root of 5 times the square root of 3 minus the square root of 5. Okay, so as you can see here, you observe, it's we have the common index, which is this 2, right? And at the same time, as you observe the radicands here, we have a sum of two difference of two squares. right? We can apply the difference of two squares here. So 3 plus the square root of 5 times the quantity of 3 minus square root of 5. Okay, it's just simply 9 minus 3 square root of 5 plus 3 square root of 5 is just 0 minus the square root of 25. And square root of 25 is just simply 5. Okay, so 9 minus 5, that's 4. So the square root of 4 is simply 2. Okay, so the answer here is 2. And then let's have another example. The square root of x squared minus y squared times square root of xy. X minus y rather. So again, same index here. So multiply the radicands. So x squared minus y squared can be expressed as quantity x plus y times the quantity of x minus y. Okay, so as you observe here, we have this. Okay, simplifying this, we have here the quantity of square root of the quantity of x plus y times the quantity of x minus y squared. Okay, and then the square root of x minus y squared is x minus y, right? And then we have the square root of x plus y. So therefore, we have here our final answer as quantity x minus y squared x plus y. Actually, you can distribute this also. So you can have the square root, x times the square root of x plus y minus y square root of x plus y. Okay. And then let's have example number 5. The cube root of 4x cubed y squared times the cube root of 4x raised to 5y squared. Okay, so again, same index, multiply. Okay, so here again, we need to extract. Okay, we need to identify the perfect root here. Okay, so here in this case, we can have the we can express this as 8x raised to 6y cubed times 2x squared y. Okay, so that we can extract again a perfect root here. Okay, the cube root of 8 is 2. The cube root of x raised to 6 is x squared. And the cube root of y cubed is just simply y. Okay, so therefore the answer here is 2x squared y times the cube root of 2x squared y. Number 6, the seventh root. The seventh root. Sorry. The square root of 7 times the cube root of 5. Okay, so here actually, as you observe, different indices, right? You have different index. So for square root of 7, that's 2, and then the cube root of 5, that's 3, right? So we need to express both radicals with the same index. Okay, we need to express it with the same index. So here in this case, we apply the fractional exponent. Okay, so which is 7 raised to 1 half times 5 raised to 1 third. Okay, so we need to identify. Actually, we use the LCD here. We use the LCD here. So here in this case, we have 6, right? So we can express 1 half as 3 over 6 and then 1 third as 2 over 6. Okay, so as you can see, we have now the same index, right? Which is 6, right? So we have quantity 7 cubed times 5 squared raised to 1 over 6. Okay, and 1 over 6 is simply the 6th root, right? The 6th root of 7 cubed times 5 squared. And let's simplify the radicand here. 7 cubed times 5 squared is just simply 8,575. Therefore, the product of square root of 7 and the cube root of 5 is the 6th root. Okay, the 6th root of 8,575. Okay. Next one. The cube root of 9 times the square root of 2. So again, here in this case, we have the index of 3 and the index of 2. Okay, so we need to use the exponent, fractional exponent here. So that's 9, which is 3 squared. And then since we have cube root, that's 1 third. 3 squared raised to 1 third. And then 2 raised to 1 half. Okay. So we have the 3 raised to 2 thirds times 2 raised to 1 half. So again, identify LCD here. So as you can see, we can have 6 again, right? So 2/3 can be expressed as 4/6. 1/2 can be expressed as 3/6. Okay? So again, that's 1/6 or the sixth root of 3 raised to 4 times 2 cube. Okay, it's just simply 81 times 8. And then we have now here the sixth root of 648. Okay, so cube root of 9 times square root of 2 is the sixth root of 648. Okay, so again, always remember if the given have different indices, you need to express them with the same indices so that you can multiply them. Okay, so be careful. Do not multiply it immediately. And then last one. Okay, for the division. Okay, for the division, we apply this. Okay, the m root of a over m root of b is equal to the m root of a over b. Okay, for instance, we have here the square root. Okay, the square root of 12x raised to 6y cubed divided by the square root of 4xy raised to 4. Okay, so again, we apply the law. Okay, we apply the law. We can have this. The square root of 12x raised to 6y cubed over 4xy raised to 4. Okay, then let's simplify. Okay, it's just like simplifying the division of polynomials. Okay, so 12 divided by 4 is simply 3 and x raised to 6, and then we have the denominator x, so that's x raised to 5. And then as you can see here, y cube for the numerator and y raised to 4 to the denominator, so that's y. Okay, so square root of 3x raised to 5 over y. Okay, so as you can see here, we need to simplify this. We need to remove the radical in our denominator. So we multiply it by y over y. Okay, so simplifying, that's 3x raised to 5 y over y squared. And the square root of y squared is just simply y, right? Okay, so we have here uh, 3x raised to 5y. So we can express as x raised to 4 times the xy. Okay, and then we can extract square root of x raised to 4 is just x squared. Okay, so the final answer here is x squared square root of 3xy over y. Okay. Another example, the cube root of 2x squared y squared all over the cube root of 24x cubed y raised to 4 z raised to 4. Okay, so apply again the rule. So we have here the rule, 2x squared y squared all over 24x cubed y raised to 4 z raised to 4. Okay, again, let's simplify. So that's 2 over 24, that's 1 over 12, right? And then since the exponent of variables x, y, z is higher in the denominator, so we have here 1 over 12 xy squared z raised to 4. Okay, so cube root of 1 over 12 xy squared z raised to 4. So again, we have radical in our denominator, so we multiply it in our in an expression so that our denominator will be perfect root. Here in this case, we multiply it by 2 times p squared x squared y z squared. Okay, so that our denominator is perfect root. Okay, so simplifying that, we'll have the cube root of 2 times p squared x squared y z squared all over the 2 cube times 3 cube times x cube times y cube times z raised to 6. Okay, so we can now simplify the denominator. So that's cube root of 18x squared y z squared. So we have uh 6xyz squared in our denominator. Okay, so say, as we divide this, we have the cube root of 18x squared y z squared all over 6xyz squared. Okay, let's have another example. The fourth root of 4 divided by the square root of 2. So as you can see here, we have again different index in the numerator and our denominator, right? Okay, so again, we need to express this with the same uh, index. Okay, so fourth root of 4 is simply 2 squared raised to 1/4. And the square root of 2 is 2 raised to 1/2. Okay, then again, 2 raised to 2 raised to 1/4, that's 2/4 or 1/2. 2 raised to 1/2 over 2 raised to 1/2 is simply 1. Okay, so fourth root of 4 divided by the square root of 2 is 1. Okay, example number 4. Cube root of the 1 over 64xy cube. So as you can see here, again, our denominator should have a perfect root. Okay, free from radicals. So here in this case, we multiply it both by x squared, the numerator and the denominator. Since 64 can be expressed as 2 raised to 6, which is we can get the 6 cube root of that, and also the y cube, right? So all we need to do is to multiply both numerator and denominator by x squared. Okay? So as you can see here, we have the cube root of x squared over 2 raised to 6 x cube y cube, which is simply 2 squared xy for our denominator. So therefore, we have here the cube root of x squared all over 4xy. Okay, so again in number 3, okay, you need to observe if they have the same index. Okay, last three examples. Okay, we have here the last three examples now. Square root of a minus b over a plus b. Okay, so let's multiply both by numerator and denominator by a plus b. Okay, so as you can see here, sometimes we need more than just one term. Okay, in our numerator and the denominator, so that we can eliminate the radical in our denominator. So here in this case, we have a minus square root of a minus b times a plus b all over the square of a plus b. Okay, the square root of a plus b squared is a plus b. Okay, so therefore our answer here is a squared minus b squared. The square root of a squared minus b squared all over a plus b. Example number 6. Square root of x plus square root of y all over square root of x minus square root of y. Okay, so as you observe here, actually we cannot multiply it by square root of x minus square root of y because we cannot eliminate the radical in our middle term when we multiply them. Okay, so now here, again, we need to use the difference of two squares. Okay, to eliminate the radicals in our denominator. So we have here square root of x plus y, square root of y, all over square root of x minus the square root of y times the square root of x plus square root of y over the square root of x plus square root of y. Okay, so here in this case, we can now eliminate the radicals in our denominator. Okay, so we have here the square of square root of x plus square root of y. And then as you can see here, we have a difference of two squares. We can apply that. So that's x minus y. Okay, so simply we have the square root of x plus square root of y all over x minus y. Okay, last one. Okay, this is the last one. 1 over the cube root of 2 minus 2. Okay, 1 over the cube root of 2 minus 2. Okay, so here in this case, uh, we cannot just multiply both the numerator and denominator by cube root of 2 minus 2. Okay, because we cannot eliminate again middle terms. Okay, but if we apply the uh, difference of two cubes, If we apply the difference of two cubes here, we can eliminate the radicals in our denominator. Okay, so we multiply it, both numerator and denominator by the cube root of 2 squared plus 2 cube root of 2 plus 2 squared. Okay, so again, you need to recall, okay, the form of the difference of two cubes. Okay, so to simplify this, so multiply the numerator and then multiply also the denominator. So as you observe in our denominator, it's just simply difference of two cubes. Okay, so the cube root of 2 cube is just simply 2. And then 2 cube is 8. So 2 minus 8, that's negative 6. Okay, then we have our numerator as cube root of 4 plus 2 cube root of 2 plus 4. Okay, so our answer here now is negative cube root of 4 plus 2 cube root of 2 plus 4 all over 6. Okay, so as you can see, uh, we need to recall the ways on how to simplify the radicals, the laws of radicals, in order to perform the operations on radicals. Okay, so you should master. Okay, you should master the laws of radicals and also the ways. Okay, the ways on simplifying it. Okay, considering again that we need to simplify, especially with this examples 5, 6, 7. We don't we eliminate, okay, we eliminate the radicals in our denominator.